Hello, welcome everyone. Welcome back to my channel. Today we are doing arcs, sectors and segments of a circle. So I'm starting with the basic definition, that is circumference of a circle. Now circumference is nothing, it's just the perimeter of a circle. That means the total length of this boundary that you can see, this one, the length of this whole boundary. That is basically your circumference. The formula to calculate the circumference of a circle is simple, which is 2 pi r. R stands for the radius of the circle. So let me do just one question. The question says calculate the circumference of a circle with radius r equals 4 centimeters. As we know that the formula to calculate circumference of a circle is 2 pi r. So it's 2 pi r. So 2 times pi and r is 4. So final answer is 8 centimeters. Well, in this questions nothing is mentioned like you have to give answer up to 2 decimal place or 3 significant figures. Nothing is mentioned. So that's why I kept my answer in terms of pi. But it's better if we use the value of pi and get the answer. But if you will write your answer in this form, that will also not be incorrect. Moving on to the next question. It says calculate the radius of the circle if the circumference of the circle is 321.4 centimeters. Okay, now moving on to the next one. Calculate the radius of the circle if the circumference of a circle is 321.4 centimeters. Now, here the circumference is already given and we have to calculate the radius. So we know circumference is 2 pi r. This value is already given as 321.4 equals 2 pi r. Now finally the radius is 321.4 over 2 pi. We just need to use calculator and directly plug in the value of pi. That means just press the pi button and when you'll solve it, you'll get the answer as 51.15 centimeters. So this is your final radius. Now most important thing is, if it's not mentioned in the question that write down your answer up to 2 decimal place, 3 significant figures or whatever, always try to give your answer up to 2 decimal place. That's it. Now the next is arc. So arc is basically the part of the circumference of the circle, and that's why to understand the arc, the circumference is important to know. As we know that the circumference is this whole length, and arc is just a part of it. Take the example of this arc AB. Clearly this arc is a part of the circumference of the circle. Well, there are 2 types of the arc. If I say arc AB denotes this arc as well. And similarly, arc AB is this arc as well, right? This is also AB. But the smaller one will be called as the minor arc and the bigger one will be called as the major arc. Here you can see in this figure, the bigger one is the major arc and the smaller one is the minor arc. Now there is a formula to calculate this arc length. Just like we have a formula to calculate the circumference of a circle, we do have the formula to calculate the arc length as well. So to understand it, we should know the angle subtended by the arc at the center. Subtending arc angle, that means this arc, when I join the ends of this arc to the center, whatever be the angle, that's called angle subtended at the center. That means the angle this arc is making at the center. So here in this case, this is theta. theta will differ from question to question. Let's say this be theta. So, formula to calculate arc length is theta over 360 into 2 pi r. Here, this is the formula to calculate arc length. Now this is smaller arc. If this whole arc will become a circle, your angle will be 360. If I want to calculate the whole circumference of a circle, the arc is your whole circle. And in that case, theta going to be 360. And if I put 360 here, 360 over 360 into 2 pi r, you'll get the formula to calculate circumference of a circle. Okay, let me do one question on it. The question says, calculate the arc length if the radius of a circle is 10 centimeters and an angle subtended at the center is 60 degrees. Now, formula to calculate this is theta over 360 into 2 pi r. Theta is 60 over 360 and radius is 10. If we solve this, we'll get answer as 10.47 centimeters. So, the length of the arc that is subtending 60 degrees at the center having radius 10 centimeter is 10.47. Moving on to the area of the circle. Area, that means the total space covered by a particular 2D figure, or this inner space, this one, the whole space, that is the area. So, whatever the space inside the circle is basically area of the circle. And the formula to calculate area of the circle is pi r squared. Here, well, this is a very common formula, we all know. Let me just do one simple question on it. Calculate the radius of a circle if area is 210 centimeters. So here, already we have area and we have to calculate the radius. We know area of a circle is pi r squared. And here, area is already 210 pi r squared. From here, r squared would be 210 over pi. This is 66.84. And finally, we have to root it to get the answer. So rooting 66.84 will give me answer as 8.17 or 18 centimeters. The next is called sector. A sector is nothing, it's a portion of a circle. It's just like a pizza slice. So which is bounded by two radii of a circle and an arc. So this is an arc. Here we can see this one whole, and these are two radii of the circle. This figure is called sector. Now clearly we have two types of sector, minor sector and the major sector. This is smaller one here. This is smaller one is your minor sector, whereas this bigger one is your major sector, because that bigger one also, like which kind of look like a Pac-Man, is also a sector because it's bounded by two radii and a major arc. The formula to calculate the area of this whole sector, whatever be the space covered inside the sector, is theta over 360 into pi r squared, which is written here. If I make it a whole figure, that means if this, suppose this is 270, now this will become whole 360 degrees, this will become the area of the circle. And here in this formula, 360 over 360 into pi r squared is pi r squared. That means this is nothing but the area of the circle. Now, the next is the chord. The chord of a circle is just simple a line segment drawn inside the circle. So this is the line segment which is drawn inside the circle, and that is your chord. The longest chord is nothing but a diameter of the circle. So this is also a chord, and this is diameter, and clearly as compared to the other chords, this is the longest one. Now the next is segment. A segment is basically a portion of a circle. So don't get confused between sector and segment. Sector is actually a pizza slice, but a segment is this one that you can see here. This is segment, which is bounded by a chord and an arc, whereas sector is a portion of a circle which is bounded by two radii and an arc. This one here also, just like we had two different sectors, minor sectors and major sectors, similarly here also there will be two types of segments, the major segment and minor segment. As the name suggests, clearly the smaller portion is going to be the minor sector, whereas the larger portion is going to be the major sector. Now, let me do some questions because this is all about the arc, sectors and segment. These all basics are important to know. We have covered it. Now onwards, we'll be doing questions on it, the simpler one, the harder ones. So see this one, it says calculate the area of the following sector. So this one is sector, and I told you the formula to calculate area of a sector is theta over 360 into pi r squared. Theta given here is 60 over 360 times pi, and r squared is 4 squared. So this will be 16 pi over 6. I've just cancelled out. 60 over 360 is 1 over 6. So, and pi times 4 squared, which is 16 pi over 6, which then can be simplified further as 8 pi over 3. So either you can leave your answer like this, or when I substitute the value of pi, I'll get, like, it all depends on what kind of paper you are giving. If it's a non-calculator paper, then leave your answer as it is, 8 pi over 3. But if it's a calculator paper, that means definitely they're expecting you to use the calculator, put the value of pi and give the answer. So on plugging in the values of pi, I'll get 8.38 as the answer. Or this is in centimeters, so answer would be in centimeters squared, because it's basically area. Now, see this question. It says calculate the area of the following figure. Well, it's given as this is a circle, then there are two different sectors, and the radius of each is given as, radius of this is given as 4 centimeters, and radius for the larger one, for the smaller one is given as 3 centimeters. That means radius of this circle, this one is given as 3 centimeters. And now we have to calculate the area of this whole figure. Now, let me calculate the area of this sector first, which is this one. So we know the formula to calculate sectors. So first thing is I'm calculating area of sector AOB. The formula to calculate area of a sector is theta over 360 times pi r squared. So theta is clearly 45 degrees here. So which will be 45 over 360 times pi, and r is given as 4 centimeter. Clearly the radius of sector AOB is 4. So 4 squared. On solving, I'll get the answer 6.28 centimeters squared. Similarly, because this figure is consisted of this sector, this sector, this sector, and this sector. So now for the another sector, which is this opposite one, and clearly they seem to be the same. That's why we are considering the radius it to be the same, or since it's 45 degrees having the same radius, so it's exactly the same. So I would be saying that area of sector or another sector is also 6.28 centimeters squared. Now, I don't know the angle of this one or angle of this one, but I do know one thing, that they both have the same radius. So, if I take this angle as theta and this angle be, let's say, theta 2. Let's say this one be theta 1 and this be theta 2. So, I'll be writing for the remaining sector, area of sector OLM is theta 2 over 360 into pi r squared, and r is 3. So 9 pi. 3 squared is 9. So you'll get 9 pi theta 2 over 360. Similarly, area of the another one, area of another sector, this one, this remaining part, is theta 1 over 360 times pi r squared, and r is 3. So 9 pi, which is 9 pi theta 1 over 360. If I'll add it, because ultimately my aim is to calculate all the areas. So now at the end I'm adding all the areas. So 6.28 plus 6.28 plus 9 pi theta 2 over 360 plus 9 pi theta 1 over 360. So this is going to be 12.56 plus, taking out 9 pi over 360 out as common, theta 1 plus theta 2. Now it's very clear, if this is 45, this is 45, and this whole is going to be 360. That means clearly the sum of theta 1 plus theta 2 is 270. Again, why? Because theta 2 plus theta 1 plus 45 equals 360. Clearly. So theta 1 plus theta 2 plus 90 equals 360. And from here, I'll write theta 1 plus theta 2 is 360 minus 90, which is 270 degrees. So I can write theta 1 plus theta 2 as 270. So 12.56 plus 9 pi into 270 over 360. So this is 12.56 plus 21.20, which is finally, so up to 2 decimal place, it would give me 33.77 centimeters squared, and this is your total area. So basically we haven't done so hard questions in this section, but it was all about the theory and some related question, so that you'll know how to apply these concepts in questions. In the next video, I'll be uploading the worksheet on it, so it will be having the simple, the medium, and the harder questions in it. So stay tuned, and apart from it, I am running GCSE classes for all subjects. Basically, I have tutors for all subjects, and we are happy to share our past results. So the important thing is, it's just that £6 per hour, it's really budget friendly. And also if you need to enroll yourself for any class for any year from year 1 to year 13 for any subject, just email us at exactacademy@gmail.com and we'll coordinate accordingly. And also, if you want to access the free worksheets, free materials that are available at exactacademy.com, so like www.exactacademy.com. So basically that's it for today. We'll meet in the next class. Take care. Bye.